Initially, your worksheets and homework are probably going to be just a variety of 45, 45, 90 triangles or the 30, 60, 90 triangles, where you're actually going to go from one problem to another, just concentrating on the values here in the ratios. But eventually you'll transfer into something a little harder, especially when you're on tests like the ACT and SAT. Those tests dearly love these special right triangles. You'll see a lot of problems on those. Those tests will incorporate more concepts of math other than just the ratio that you're going to see here, the 45, 45, and 90 triangles. It will be using that information in order to find area or perimeter, or else you're going to take that information and somehow relate it to another similar triangle. Also, the numbers that you'll be using won't be as easy as 3 and 5. So let's get an organized way that you can think about this from the get-go, because initially some of this is fairly easy. But if we have an organized and methodical way that you can go about the easy problems and the hard problems, you're probably going to give yourself more success in the long run. So we'll start with the 45, 45, 90 triangle. And so I've set up the three angles that correspond to the opposite sides, because that's what you're finding. In this case, the 45 degrees is coupled with the x term. So it's x, x, and all right, now that we have our triangle, we can mark our sides. Across from the 45-degree angles are the x's, and across from the hypotenuse, remember that box actually points to the hypotenuse. So this would be x radical 2. We're going to give this value of 5. So we're going to come over here to our chart. So if x is 5, then the other x will also be 5. And we're going to put our 5 in where we see an x here, radical 2. Now we've got all of our lengths of the sides here. So this is going to be a 5, and a 5 radical 2. From here, if the problem asked you for the perimeter of this shape, you could just simply add up your, and then we're going to have to give this one a separate column, because that would put us into a binomial with the rules for these type of numbers. So we're following other rules of math when we do the actual perimeter of this. Boom, problem's done. Finding either one of the legs of this triangle would help the most. It would be the easiest way to go. In this case, we have one of the legs measuring 23. Well, that makes the other leg 23 as well. And then the x fits right into this position right here, so we'd have 23 radical 2. And our information would be complete. Now if we wanted to do a perimeter of this, let's say we had 23, we have 23, and we have 23 radical 2. We would simply start at one of the vertices and add up the figures around it. 23. This one I can't use right now because it's a whole number and a radical, and those are separated from just the whole numbers. So we're going to put together combined like terms, and then this one is just put on like this. So that would be the perimeter, P equals. That's another x term. We can copy it right here in our chart. That helps us. And then over here, we have 17 radical 2. If we have 16 as the hypotenuse, that's a little more difficult than just copying the x where you see it. 16 is the x radical 2. It's not just this x portion of it. It's the whole thing. So when I go back to the other places, I have to actually do a calculation, because this 16 means 16 is equal to x radical 2. So in order to solve for x, I'm going to have to divide by a radical 2 on both sides. Now this 16 radical 2 needs to be simplified. We cannot have a radical in a denominator. So we're going to have to pull this out by multiplying by the same. Radical 2 times a radical 2 gives you 2. And the top is 16 radical 2. Now this one isn't quite done yet, because we have whole numbers. We can actually do a division step with the whole numbers here, because 2 is divisible into 16. So this then becomes 8 radical 2. And that is our x value. So now we can go back to our chart and fill in the rest.